In this video, we demonstrate the azimuth plotting of the reference horn using MAT12 40 MHz to 12.4 GHz RF and microwave antenna training lab. Now we will set up the signal generator to a frequency of 4000 MHz. We have not to apply any modulation, so it is generating a frequency of 4 GHz. The 4 GHz is available from this SMA connector. We're using a long RG316 SMA cable, and it is applied to the antenna, the reference horn. The reference horn is right now in vertical polarization. Now we have to adjust the microwave signal analyzer to start listening to a frequency of 4000 MHz. We've set it up to a frequency of 4000 MHz. The power level right now is being displayed as -30 dBm. We have connected the receiver to the antenna under test, which in this case is also a dual ridge horn antenna. The current power level is -30 dBm. We will activate the auto stepper function. In this case, the auto stepper is blinking and the receiver is ready to listen to a pulse from the stepper motor controller through a BNC cable which is being connected to the stepper motor controller. The memory location currently displayed is 0. So on receiving a pulse from the stepper motor controller, the receiver will advance its memory location and record the power meter reading into the memory location and move on to the next memory location. So in case we rotate the antenna in steps of 5 degrees, we will have 72 memory locations which will be advanced. Now we move to the stepper motor controller. As you can see that the stepper motor right now is displaying 0 degree as the current location. The total position is 360 degrees. We have to advance in steps of 5 degrees. We have already connected the antenna under test onto the rotator. We have made sure that the vertical alignment of both the antennas are in one plane and the antennas are pointing towards each other, and we have connected a BNC cable between the stepper motor controller and the signal analyzer. We have disconnected the USB cable going from the PC to the signal analyzer in this case. Now we press the start button and we can see that the antenna starts to rotate. Now this antenna is rotating in its azimuth plane and in steps of 5 degrees. For every 5 degree step, it is giving out a pulse. This pulse is basically being fed to the signal analyzer, and the signal analyzer is recording the memory location. As you can see, about 180 degree has already elapsed. We need to make sure that the cable does not tangle itself. As you can see that the power level reading is changing dynamically, as is being visible from here. So right now the device under test, which is a dual ridge horn antenna, in this case it is being rotated in its horizontal plane, which is the azimuth plane right now. So the receiver has logged a total locations of 72 power meter readings into its 72 memory locations, and we can now disable the stepper function. Now we have to dump the memory data to the PC. Now we will start to tell you, before we dump the data, we need to prepare the PC to use the COM port and install the software. As you can see that the CD will come with these files into the software CD. So we will have a LabVIEW runtime environment 2011. We need to execute this file, which will activate a LabVIEW runtime environment, which will allow us the software compatibility between various operating systems. The system will also come with a USB serial driver. We are using a Silicon Labs USB to serial port, and as you can see, there are two files right now: CP210XV installer, x64 and x86. So if you have got a Windows 7 PC with a x64 architecture, you need to run this file. In case you are using a Windows 7 with a 32-bit architecture, you need to run the x86 file. Now executing this file will basically install the driver for the USB to serial COM port, and in the device manager in the computer we will start seeing the USB to COM port. Now as you can see, right now there are no COM ports, but the moment we will install the cable, we will be able to see the devices. Now also we have to install the polar plot installer file. This is self-explanatory. We have to run the setup, and this setup will install the software for the antenna polar plotting onto the PC, and will place a icon onto the desktop which we will run to execute the file. Now as you can see, as we connect, now there is a small bip, and in the COM port we can see that a Silicon Labs USB to UART bridge COM3 is right now placed. That means that the device has properly installed and the device recognizes our COM port. Now icon is being placed, we will execute and a window will pop up. Now this is the software GUI for antenna polar plotting. As you can see, this has various menus which are right now in default condition. In default, it is going to plot level versus angle, and it will be in a polar coordinate. It right now has set itself to a location from 1 to 72 and various other small options. So we will basically click this button here, which will start the software into the listening mode, and then we will dump the data into the PC, and all the memory locations from the receiver will be dumped to the PC, and we will be able to take a polar plot. Now you see a COM15 right now. So a COM3 has been detected, and we were right now going to run it into the legacy mode, and we press the enter button. Now we come back to the receiver, we press the memory button, and we press the dump data. Now as we press the dump data, the receiver will dump all the memory location into the PC USB port, and if you see closely, there is an indicator here which starts running in different shades of green, which indicates that the PC right now is listening to the receiver, and all the memory locations are being uploaded into the PC. The signal analyzer has about 10,000 memory locations, so it will dump an array of 10,000 memory locations with 10,000 frequencies and 10,000 power meter readings. So it's going to be a sizable file which will take a minute or two to upload. So once we have uploaded the file, we will choose to save the file into a particular location. So as you can see, this is the plot for the dual ridge horn antenna at 4 GHz, and we can see that as we have a front to back ratio of about 24 dBs right now, we can activate the cursor modes, and we will be able to take out the 3 dB beam width and other antenna parameters from this polar plot. Then we have to basically replace this antenna under test to different antennas which are being provided with the system.